Well, hello YouTube Nation, and welcome to Simply Cinemaric Live, the live YouTube series that concentrates on key features and functions of the 828 control, as well as a lot of industry tips and tricks that really apply to any CNC machine. I'm your host, Chris Pollock, and this is our Virtual Technical Application Center, or as we like to call it, the VTAC. So today you're going to get an opportunity to see the 828 in action using the swivel cycle and applying it to the Big Kaiser AGU 90 swivel head. So what we're going to see is we're going to see how we can apply swivel head technology to a basic 3-axis machine tool and really fundamentally turn it into a 5-axis kinematic. Now granted, it's going to be a manual 4th and 5th rotary axis, but with that being said, it still allows us to get into any orientation angle that I want, similar to a traditional 5-axis kinematic. So we're doing this again through the Big Kaiser AGU adjustable heads, the AGU 90 adjustable head. They have a whole series of adjustable heads for different applications. What I certainly like about this one is it gives us a lot of range of motion. So we're going to get into some of the key features and functions. And with that head has been integrated on our Fryer CM20 compact mill. This is a vertical, this happens to be a 4-axis kinematic setup, but this is what allows us to really show off a lot of these key features and functions. So you're going to see a lot of this machine in the future with this series. So with that being said, let's talk a little bit about the function that you're going to see and kind of what it's going to do for you as a user or an operator. So once set up, the swivel cycle is actually going to give you a function within jog as well as with auto mode that allows us to basically orientate our tool plane. So by coming into swivel, I can enable a set of parameters that you're going to see how we set it up and activate and really rotate our tool plane into any orientation or to match the tool plane on the machine. So here you see an interior shot of my machine tool. And normally our coordinate system, like you see on my little cube here, is pointed straight up at the Z-axis orientation. So if I was to jog the machine right now, and we'll bring her up, you see how the Z itself, as I'm jogging Z, or if you can see on the display as I see the Z is moving, I'm moving normal to the machine spindle. Problem is, how do I handle drilling, milling, doing any of our can cycles, cutter comp at some orientated plane? So we see here I have this tool set up at a 45-degree angle. So fundamentally what I want to be able to do is tip my coordinate system, align the coordinate system to the Big Kaiser head, so now all my can cycles are going to work at this orientation angle. That's what the cycle is going to give us. So through the swivel cycle, I can come in and I can tell it an angle of rotation. So the angle of rotation is going to match the angle that I've set on my rotary head on the axis that revolves around my Z in this case, and then an angle of orientation that's going to be revolving around my Y-axis. In my scenario, the way I have this machine set up, I have a value of 180 and a value of 45 input in the swivel mask. So when I hit cycle start, the system is now going to take these two values into account. Now what it prompts me to do, and the way we've set it up, is to work as a manual axis. So with a manual axis, the system is going to command me to move the rotaries manually to these axes. So I've already pre-staged it for us. Final cycle start. And now what we've done is we've actually changed the orientation of our coordinate system. So if I now do the exact same move I did before, I am going to want to turn on our WCS mode. That is now saying that my jogging motion will match the work coordinate system because that has been tipped. We jog back and you see I'm actually getting an X and Z move, but that is what allows my tool to position or move relative to this rotation, relative to this coordinate rotation. So once this is established, whether it's in a part program or here in jog, I can now utilize my can cycles in this orientation value, in this direction. So this is fundamentally what we're going to show you. We're going to start with going through some of the very high level basics as far as setting up the feature. Then we're going to show you a quick overview of how I would touch some tools off, and then even give you a little product demo with a live cutting demonstration. We're not going to physically cut. I've already pre-cut the part, but we are going to run a part in auto so you can see internally how we can start moving relative to these coordinate rotations. Now, this is the first of a 3-part series. So what we're going to do here is we're going to go in and do a part 2 in a couple days, and part 2 is going to really dig into the inner workings of how I would set this up. So we're just going to give you a very high-level overview of how it would get set up. So if you're a guy that wants to be able to commission this type of functionality, whether you work for an OEM or an integrator, I would certainly tune into our next step, our part 2, and get into that functionality. Then for those operators and programmers out there, part 3 is going to go in more detail of how I really set up the offsets, and we're going to see how they interrelate. Again, this is just giving us an overview today so you can get a kind of a high-level view of what this function does. So how do we get the swivel cycle first to appear up on our screen? That's important. So the swivel cycle itself is not a billable option. A lot of people would think that you need to have a license to get the swivel cycle. It doesn't require that, but what it does require is you do have to have some machine parameters set up. So inside of our setup area and machine parameters, there's some MDs we would set through general and channel MD. We will go into those when we do part 2 in detail. But really the big one for us to take note to is MD 52212. So when I take a look for 52212, it's what we call a hex bit, and inside of here, this first bit 0, this is the bit that basically enables that function. So I didn't have to turn on any licensing. But what that's going to do is going to do 2 things. One, it gave us the swivel cycle button that you were just seeing in auto. It also gives you the additional function in, or shall I say in jog. It also gives you the additional function in auto mode. But what it also did was back here in the setup parameter areas, it gave us what we call our swivel data mask. And the swivel data mask is what really starts to support the values that are feeding this type of attachment, this type of head. So if we go back and take a look back at our machine interior view, there's a couple pieces of information I need to know. I need to know a distance from a gauge line value, so probably my spindle face, to a center of rotation. I need to know a distance then from the center of rotation out to the tool tip. Now, this value is a constant, obviously, distance from spindle gauge line to center of rotation. And then what I want to do is I probably want to make a constant at least out to some datum here. Not all the way to the tool tip, because that's going to change, right? As I put different tool offsets into the machine, that is going to change the value that's there. So what we're going to do is we're going to establish a value from the center of rotation, and I did it out to my collet face. If you have a quick change holder, some units do, you could have that value to the quick change, and then I could swap these out at will. This one has just an integral collet, so I established it to a collet face. So if I put a stop or something in here, I could change the tools even mid-program or mid-process if I needed to without having to fully retouch all the tools off. And those values are what gets plugged into this table you're looking at here. So for those of us that get on a machine that has the swivel cycle enabled, whether it's full 5-axis or a 3-axis with a couple manual rotaries like we're doing today with the Big Kaiser adjustable head, you can see those lengths are plugged into different vector components within what we call the kinematic chain, or the chain that establishes where the tool tip is. So I have a value of 7.086. That's the distance from a gauge line to center of rotation, and then a value of 3.8 and change is the distance from center of rotation out to here. Now, part 2, we're going to show you how to measure those. We're going to show you a lot more detail. We'll actually create a full table. So if you guys are certainly into that level, come on back. Additionally, you do have to set up the rotary axes. So what I did in mine is I called the rotary that spins around my spindle the C axis, because that's an industry standard for that type of physical kinematic axis, right? That would be the ISO standard. Any rotary that revolves around my spindle is defined as the C axis. And then we have the B-axis. So the B-axis, the ISO standard would be, that's the axis that would rotate about the Y. So I just use those two values. But of course, this machine doesn't really have a C and a B. It knows they're manual because we've chosen the manual selection here in the setup mask. So from there, it now has enough information where I can actually start to use this feature, this function. So we're going to back out of setup, and we're going to talk a little bit of how we would apply this function in a real world scenario. So the next step is setting up my tool offsets. So what I've done here, and we go back to the jog area and we can start to set it up, we have now a compensation value from our gauge line to center of rotation and a secondary value that comes out to the collet face. So now I have to compensate for this tool length, right? This projection out. And that's going to be my variable dimension. So that is part of the tool offset. So step one would be to create a tool offset for this tool. I do that by going into the offset table. Now, for those of us that have actually set up a right angle head in a Cinematic control before, you probably used one down here like this, which is predetermined as an angle head. And when you set up the machine as this type of angle head, you're actually managing this orientation, right? These two lengths that I just talked about in the swivel mask here internally in the tool. The problem is this can be pretty limited. One, I can only build a couple basic tool types. So if I needed to do a ball end mill or something else, I would have trouble getting into some more of the complex geometries. Excuse me, my throat's a little dry today. And when it comes to actually plugging in the values, I have to figure out vector orientation, lengths. It's a little more detailed part of setup. Once we do it with the swivel cycle, now I can use any tool within our library. So in my case, I built it as a drill. And then that's the tool that would get inserted into this component. Now what I have to make sure is I do have the swivel cycle mask called up before I set up the tool. Because if I don't have it, it then won't take those values into account, those two offsets that I needed to know. So all I did was I just zeroed out. Now I have two separate offsets here because I want to show you two different ways of setting up this tool. One, we're going to touch off the tool in a vertical orientation. Second, we're going to touch it off in a horizontal orientation. So for us, what I've done is I've preset a 0, the center of the part. That's the one we're going to use for our part program. But I also set a second 0 on this edge. So by activating two different work coordinates and then touching off to that datum, I can show you that we can set up this tool in any orientation. So I'm not limited to having to force the tool to be vertical when I set up the offset, or maybe in a 90-degree orientation. We're going to show you both. So in the first one, I do want to make sure I have cutting edge 1 loaded. So I'm just going to do that through my tool change field. Okay, cycle start. And this is going to load that first offset. And now what we're going to want to do is we're going to want to straighten up the head. So the way this head works, it's pretty cool the way it works. I can adjust my spindle orientation by loosening up 6 bolts. There's 3 in the front and 3 in the back. And then I'm going to use this set screw, and it's really a precision tip set screw, to really bring the tool orientation into a specific angle. So with these, I can get anywhere from 0 to 10 degrees and anything from 0 to 90 with quite a bit of precision. Now, if I needed to be at a value in between a degree increment, then what you're going to do is you're actually going to put like a dowel pin in here and indicate across that surface. And that's where having the swivel cycle back in jog becomes really handy. And we're going to explore that in part 3 and show you how I can really set all that functionality up. But for this case, we're going to come in and we're going to loosen up our 6 bolts. And then I'm going to back out this set screw because no longer do I want it locked in at a 5-degree increment sitting at the 45-degree angle. But I want to set it at 0 first. So I'm going to bring it down. There is a scale up under here that I can set the 0 and I can come up and look under. And when I get close, I'm then going to bring in the corresponding angle input that matches. So in this case, I'm going to 0 because I want to be at 0 degrees. Now as you start to screw it in, this should go in nice and easy. If it doesn't, just move the spindle a little bit because you're outside of the range. We snug that up. Then we would tighten up all 6 bolts. I'm not really running this, so I don't have to go crazy tightening it up right now. But certainly if I was going to start machining, I would want to tighten up all the bolts. Now from here, I do have to make sure I'm activating the swivel cycle because it's going to use those values into account. So go into Swivel and tell Swivel how we're orientated. So I'm still sitting at 180. I didn't spin around. It really doesn't matter anything for the vertical orientation. But I need to tell it my B is at 0. So I go to 0, hit cycle start. The machine is now going to tell me to move the axes to 0. I hit cycle start again. And now I've established this orientation. So at this point, it's really as simple as coming over and touching to whatever we established our datum surface to be. So in my case, I'm going to move the machine over and we're going to physically touch off to the top of this surface. So we're going to jog the machine, get her close. And I want to make sure that G54 is active. Let me turn on G54 because that is the work coordinate that I set up based on this plane. So I've already probed the top of this part and it knows that to be 0. We're going to bring our Z down, get it kind of close. All right, so now I'm just going to use my hand wheel, move the machine down. I'm going to use the old paper trick here. So it just allows me to bring her down to a known datum. Certainly, I may want to do something a little more accurate depending on what kind of tolerances I'm trying to hit. For speed's sake, this is a quick, down and dirty method of touching off a tool. So I bring it down to my plane, and now I have to tell the machine to set the offset. So just like I would normally set up a tool, I go to Measure Tool, Length Manual, I hit Set Length, and it's going to then calculate or compensate. So what the system just did is it said, okay, well, since I know these other numbers, I know the 7-inch and I know the extra 3.8, all I had to do was figure out what's left over. So if you go back to the offset table, I see I got a 1.6049 offset. So I would buy that that's sticking out about 1 5/8 inches. That certainly makes sense. So what if I had to touch it off, but my tool was already tipped or had been adjusted to another angle? Well, I can use Swivel and really get it into any datum angle and touch it off there. So this is where I'm going to use that second work offset. So I had pre-selected or preset a work offset back here, my G55. Oops, need to go over to work offsets and TSM. Cycle start. Okay. So now G55 is now active. I still have to manage my orientation by going into Swivel. And now I'm going to tell it what I'm going to do with the axis. So I'm going to tip my B up to 90 degrees. Hit cycle start. Prompts me. Now we do have the ability of telling the machine to go back to a safety retract location. That would be inside the swivel mask. That I set this retract to a yes value and I can predefine locations. So there's actually a lot of functionality you can do within the swivel cycle, and it's really quite unique to the Cinemeric control, how much capability you get and how really kind of easy it is to start to apply. Okay, so we'll loosen up our bolts. So if I was only worried about getting this within a degree increment, then I would do exactly what I'm doing. If I start moving around the rotary, then you may want to actually indicate in the physical unit by, again, putting a dowel pin, something along like these, chucked in. And then as I adjust it, I can indicate across and square up the unit. I'm going to go back to 0. Snug it up. And you don't have to go tight on this by any means, just until it stops. We'll snug up these bolts just because I'm moving around a little bit, but I'm not going to go crazy. Certainly if I was going to machine, I would tighten that up. And now we're going to go to this datum surface. So I already probed and found that edge earlier just to save some time. Now when I'm moving the machine around, I can actually have the machine set up to allow me to move the rotaries relative to the machine coordinate system or the work coordinate system. So sometimes it's easier as an operator to not think about how the machine's been tipped around, but only think about my physical axes, right? So that's what I'm doing right now. As I crank the Z-axis, I get a Z-axis move. If you look at the display, I'm actually getting the Z moving when I crank X because my coordinate system has been tipped by this cycle. All right, that's close enough. I just grabbed a little bit of the paper. So here I have an active tool offset, and we see I'm within a few thou, certainly, of that. Could be the difference of me pushing on the paper a little bit. But I can go in, I can measure my tool offset, set a length manual, and now it would update that offset to that appropriate position. So I can, for all intents and purposes, set my tool offsets at any orientation angle, as long as I use the swivel cycle here in jog to manage that orientation. At this point, we could certainly then start to move the machine relative to that coordinate system. Now in our case, we're going to do things at a little bit more of a compound angle. So for us, I'm going to set this head at a 45-degree axis, because then we're going to show you a programming example and show you kind of how this works a little bit. So if I want to get this head, if I want to get the AGU 90 head set at a 45-degree angle, I'm going to come in and I'm now going to, looking at the scale, swing the head down and set it to 45. So this one, I like to try to get it as close as I can. So I'm backing out the set screw like before. I'm going to rotate it down. And I will be honest, the eyes aren't what they used to be. So I'm going to grab my cheaters here. All right. And looking at the bottom, I get it within the scale. And now I got to make sure I go to the 5-degree because I want to get to 45 degrees. And this is what really gives me that precision. If you actually watched it, you can almost see it moves the head down, brings it right into position. Okay. We'll drop our Allen wrenches. Why not? Of course, there's chips down there because I cut this part the other day. All right. So now the unit is snugged up, certainly enough for us to run it. Okay. So now our next step is to show you how I can then apply this in a real-world example, in a part program example. So the part you see here, this little cutaway and has these orientation angles, we're going to just show you the operations that come in and do the drilling orientation. I'm actually doing a little bit more than just drilling. Previously, I obviously milled all these surfaces with the head as far as the 45-degree planes and the compound 45-degree plane. And then I took another tool to relieve it out so we could see what's happening internally. So from a programming perspective, and we'll just zoom in here a little bit for you, make it a little easier to see. I have a part program that I've created, and this is the full program. So this does all of the operations. So it allows me to come in, switch between standard tools like my metal mill 1 instrument that I did a lot of the peripheral milling with, and then also use the swivel cycle to establish an orientation. I can move my zero around the swivel cycle. So if you haven't seen how the swivel cycle itself works, I would strongly suggest checking out one of my webinars. I've done a couple webinars on this, both conversational and G-code, so take a look at both of them. Again, this one's conversational, but it would work the same way if I was doing G-code or maybe it was being posted out from our CAD/CAM system. So this program we're going to simulate, this shows you the basics of what the tool path would look like now when I'm prompting it around. And at every orientation angle, the system would then ask me to adjust. All right. And we'll slow her down. So now we're putting in our compound holes, I had the override set up a little bit fast just to save some time. But you see how we're now coming in, drilling normal to a surface. So what's great about this is it really established G17 to be that plane. So now all of our can cycles are going to work in that orientation. So I didn't just drill. I used the facing cycle to mill on that plane, but I also used this tool to do some counter boring and some chamfering. I actually opened up the size of the hole with a pocketing cycle. This tool itself that's in the spindle is what's called a mill drill. So it allows me to take a side axial load or mill. So basically it's an end mill that's been ground with a 90-degree point. And you're going to find when you utilize tools like this, you're going to get pretty creative in your tooling, because we'd all love to buy 10 of these Big Kaiser heads. But let's face it, these things are a decent investment. So you probably only have a few available to you. So you're going to try to want to get as much use out of as you can, as many operations. So this drill allows me to drill. It allows me to go in and chamfer. I can do basic pocketing or open up the sides of the hole, maybe a little counter bore action to it. And then certainly I came in and did a final relief just so we can see the interior. Now the program we're going to run, that I just took out the milling features. So our demo is really just going to handle the drilling. But it's not just drilling. So if you look, I'm drilling a hole, right? We're coming in and we're drilling the hole based on each of these orientations. I got it there by establishing the swivel plane. I can tell it my angles of rotation either by doing what we call coordinate rotations or the direct axis. It can use either one, but the system will calculate and tell you where to move the rotary to as an angular value. But I also can use it then for pocketing. I can use it for doing chamfering, any of our cutter compensation. So everything I could do in a standard vertical plane can be done at any orientation I want. Hence really giving you 5-axis capability in a basic 3-axis machine tool. So let's take a look and see what this would look like. So we come into auto. Let us switch over to our interior view, because this is where it gets fun. I'm going to throw some safety glasses on. I mean, we are not taking any chips here, but just always be safe. Start it up. Now it's going to prompt me as it gets into a safe location to set the tool. So if it's preset, I can let it drive by. There are ways to set up the cust cycle, which we'll talk about in part 2. So if I don't want the machine to pause, maybe I'm tool changing this head and we're just keeping that same orientation. But now you can see the machine is moving relative to that orientated plane. So it handles my drilling cycles. Now I'm doing a little circular pocketing. So anywhere within the range of motion that I'm capable of getting to with the Big Kaiser head, I can now utilize any and all of our can cycle features. And again, same thing with G-code or conversational. Here's my little chamfer. Hopefully you guys like this format. So we're going to start to do a lot of this YouTube live functionality. Now, I've been doing webinars for a long time. This really gives me a chance to kind of show off the product firsthand. You know, there's only so much you can do in a webinar format showing a PC emulation of the control. So a lot of the stuff that we weren't really able to dig into from the webinars, we're going to really use this format. So by all means, if you enjoy the video, please like it, follow the channel. If you hit the little bell, that'll give you a reminder. So if you're interested in checking out part 2 or part 3 or any of the stuff I have coming up, just check that bell and you'll get a reminder. Now in this case, we did our first operation. It's telling me on the control I now need to change my orientation. So for this scenario, I got to get over to this hole. So one of the things it's asking me to do is rotate about my C-axis on the display to 315 degrees. So when I want to rotate this head, what I'm going to do is I'm going to loosen up this collar. There's 2 bolts that loosen up the collar. And then I'm going to spin or adjust the tool to this orientation. So we're swinging it around. So if there's a little scale, you probably can't really see it all that well on your end. I can certainly see it here. But we can come in. So I got 305, 310, 315 if I want to be absolutely sure. So with this angle, you know, if I'm doing something where all I have to hold is, you know, plus or minus maybe a half a degree or so, you can certainly see that based on this scale. But if you're trying to hold anything of any precision beyond that, then what you're going to do is you're going to indicate this in. But that wouldn't allow me to then obviously change orientation mid-program stream. So that would be a good reason if I had two different orientations, maybe I would need two different heads. Or I would just do all the ops, you know, old school, and then set up again and do all the secondary ops with the head of the new orientation. So I just couldn't do a complete part every cycle run. You're going to have to adapt the process a little bit. Okay, so we are now adjusted at our 315. We initiate our cycle start. The machine is going to go up, and if you see the motion, how it's moving down, it's actually moving in what it thinks is an XYZ orientation. Give you a little closer view. And now our Z is now aligned to this compound angle. And again, using the same style can cycles. So we're drilling at that orientation angle. Now what happens if, oops, I kill it, I shut it down? Well, that's okay. So depending on how I set up the parameters, the system will maintain that orientation angle. So right now, if you look at the control, it might be hard for you guys to see, but there's a little X and Z symbol telling me the coordinate system's rotated. Well, I can come back into my jog screen, and as long as I use this WCS mode, and I go to jog, I can now jog out of that hole, tracking that orientation angle. Additionally, I can certainly come in. Maybe I wanted to do a mid-program restart. We could start the program up again at this orientation or swing it back and continue on. So as I mentioned, we're going to go through in more detail in part 2 and part 3. Part 2 is going to get deeper into this commissioning or the setup side of the physical function. And then part 3, we're going to get into the setup of the tools a little bit more, creating tools, seeing the interrelationship. We'll do some probing. So hopefully you guys can make it back. Let me take a look. We do have a few comments. Everybody's saying it's a much better stream today. Yes, we had some technical difficulties yesterday, but I think we worked it out. And looks good. So I don't see any too much in the way of questions here. You guys can always reach out to me if you do have any questions. I want to again thank you for taking the time to check this out. Video is going to be posted, so you'll be able to reference it in the future. And again, keep an eye out for more videos. We're going to be doing a lot of our Simply Cinematic Live series. So I really enjoyed getting a chance to talk to everybody, and I can't wait to talk to you again real soon. Thanks, and have a great day.